Alright, so in tonight's video, we're going to cover rational exponents and nth roots, where n is just going to be a variable, so we're going to have different rational exponents here. And rational exponents, again, just means we're going to have some fractions as our exponents. Alright, so what is an nth root? And I put radical in parentheses because nth root we're going to be able to rewrite if we want to. We're going to rewrite as a radical. The most common radical that we've seen over and over again in our math life is the square root. And the square root doesn't normally have a number outside the radical because it's just an understood 2. So if you see a radical just sitting there by itself, just assume that that's the square root, which we've always done. But there's a pretend 2 there, or an understood 2. And our radical property, which I circled over here, says that the number outside the radical, when we rewrite as an exponent, the number outside the radical, in this case is n, becomes the denominator of our rational exponent. The number inside the radical, or the power that we're raising it to, in this case m, becomes the numerator of our rational exponent. So the number outside the radical becomes the denominator. The number that we're raising our radical to, or the exponent, becomes the numerator of our rational exponent. So on 1, 2, and 3, in the cubed root, square root, and fourth root examples, we're not raising our radical to anything. So that's just going to be a 1. So we're going to have an x. Going to have an x. The number outside the radical in my rational exponent is 2. So the denominator of my rational exponent is going to be 2 because that's the number outside the radical in the square root. And I'm raising it to a 1 because I'm not raising it to anything in these examples. So the cubed root means there's a 3 outside of my radical. We're still just raising it to 1, so that's going to be my numerator. The number outside the radical is a 3. So the cubed root is going to be the same thing as writing x to the 1/3. The square root is the same thing as writing x to the 1/2. The fourth root means we have a 4 outside the radical. So the fourth root is the same thing as writing x to the 1/4. And in class tomorrow, we're going to write rational exponents and radicals just back and forth. We're going to go from radical to exponent notation and then from exponent to radical notation. It helps us solve stuff in the future. Okay, so I have a couple examples down here. In the first example, we have a to the 2/3, and we want to rewrite a to the 2/3 in radical form. So we're going to turn the exponent form of a to the 2/3, and we're going to convert that to where it has a radical. So if I'm writing it in radical form, I know I'm going to have a radical. The denominator of my exponent is the number that goes outside the radical. So since 3 is the denominator of my exponent, we're going to have a 3 outside. Then a is going to be in here. And the numerator is the number that we raise a to. So since the numerator of my exponent is 2, we're going to have a squared inside. You're also going to see this notation where you write the 2 outside the radical. It means the same thing either way. It doesn't really matter which way you want to write it. Sometimes it's more beneficial for us to write it in the parentheses squared, like the second notation I just wrote. For a non-calculator part of the test, it's probably going to help us to write it like that so we can solve it in our head. But they mean the same thing, and you'll see me write it both ways if you're looking at my key. Okay. The second example is already in radical form, and we want to write it in exponent form. So we're going to work the other way. So the base of my exponent is still a. The denominator of my rational exponent is the number outside the radical, which is 4. the number inside the radical is the numerator of my exponent. So we're raising a to the power of 3, so that means the numerator of my exponent is going to be 3. All right, so that's the basics of how we convert back and forth. Now we have some more examples that we're going to simplify by rewriting most of them. Some of them we won't, some of them we will. So, simplifying these expressions, if we have a radical times a radical, and they're the same, so we have, in number 1, we have the cubed root of 16 times the cubed root of 4. Well, we're going to say, since they're both the cubed root, we can say that that's the cubed root of 16 times 4. Since they're the same radical, they're both the cubed root, we can put them together and put the numbers underneath and multiply them together. So 16 times 4 is 64. And the cubed root of 64 is 4. We can find the cubed root in our calculators. There is a non-calculator portion, so there are going to be some simple things that we'll have to know how to take the cubed root of. But to start in class, we'll be able to use our calculator to help us at the beginning. And then we'll see the cubed root of 64 and other numbers like that a lot, so we'll get used to learning that that's 4. So number 1, if we had the same radical and we were multiplying the radicals together, we could combine the numbers inside and multiply them. Number 2 is the exact same thing, except we're not multiplying here, we're dividing. So we have the 5th root of 64 divided by the 5th root of 2. Well, just like the last problem, since they're the same radical, we can say that that's the 5th root of 64 divided by 2, because they're the same, so we can just put the numbers inside together, which 64 divided by 2 is 32. And again, we can use our calculator here. This will be a popular one that we see as well. So we'll need to know that the 5th root of 32 is just 2. But again, in class tomorrow for our first day of practicing this, we can use our calculator to help us with that. Don't think you got to memorize that yet. So 32 to the 4/5. This is why going from radical to exponent, exponent to radical can be helpful. Because 32 to the 4/5 we can use a calculator to do, but we're probably not going to be able to do that in our head. But if we write this in radical form, we'll be able to do it without our calculator in a couple days. Maybe not tomorrow. You still may need your calculator for assistance. So, remember that the denominator of my rational exponent goes outside the radical. 32 goes in here, and I'm going to use that other notation where we put it in parentheses and raise it to a power. The numerator of my exponent is what the power we raise it to. So the denominator of the rational exponent is the number outside the radical, which in this case is 5. The numerator of the exponent is the number that we're going to raise our radical to. So the numerator of my exponent here is 4. So that means the power that I'm going to raise the 5th root of 32 to is 4. The 5th root of 32 we just found in number 2, example 2. We said that that was 2. So the 5th root of 32 is the same thing as 2. So we're raising 2 to the 4th, which is 16. And 2 to the 4th we should be able to do, because 2 times 2 is 4, times 2 again is 8, and times 2 for the 4th time is 16. All right. Number 4 is simplifying radicals. So here we're going to have to simplify these individually. So the cubed root of 16y to the 7th we can think about as the cubed root of 16 times the cubed root of y to the 7th. You won't always need to simplify like this, but this is what we're going to do when we're simplifying. It's simplify each piece by itself. So the cubed root of 16 is not a pretty number. If we plug that into our calculator, it's something like 2.52 or something like that. It's 2.5-ish. If it's not a whole number, we're going to simplify the cubed root just like we simplified square roots in the past. So when we simplified square roots, we took the number inside, 16, and we wrote our factors of 16. So we have 1 and 16, 2 and 8, and 4 and 4. And when we simplified square roots, we said, well, do I know the square root of any of these factors? Well, if I want to simplify the cubed root of 16, we're going to say, well, do I know the cubed root of any of these factors? And I do. Wow, that's way too thick. I know the cubed root of 8. So we're going to say that the cubed root of 16 is the cubed root of 8 times 2, because we're going to choose these factors because I do know the cubed root of 8. And the cubed root of 8 we know is 2. I don't know the cubed root of 2. So the cubed root of 16 we rewrote as the cubed root of 8 times 2 because I know the cubed root of 8. I know the cubed root of 8 is 2, so that can come outside the radical. But I don't know the cubed root of 2, so that stays inside the radical. So the cubed root of 16 turns into 2 cubed root 2. And that's simplified. So now I need to simplify the cubed root of y to the 7th. Well, the cubed root of y to the 7th, to take the cubed root of a variable to an exponent, we're going to want to divide. But 7 doesn't divide by 3 nicely. So let's go on a brief little tangent over here. So y to the 7th means we have y times y times y, 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 y. Means we have y 7 times. Well, the cubed root of y cubed we know is y. So for every 3 y's we have 1 y cubed. So here we have y cubed twice, right? So since we have y cubed twice, that means we're able to pull out y squared. And what was left over is y. So how many groups of 3 y's, because it's the cubed root, which is why I boxed 3 of the y's. If it was the 4th root, I would box 4 of the y's. If it was the 5th root, I would box 5 of the y's. So since it was a 3 outside my radical, I'm going to put a box around 3 of the y's. And since I was able to do that twice, that means we can take out a y squared. So how many of those groups we're able to take out becomes the exponent outside the radical. So since I was able to take out 2 groups of 3 of the y's, that leaves me with y squared. And then this lonely little y over here is what was left over after I took out 2 groups of 3. So that just stays underneath the radical. All right. So the cubed root of y to the 7th turned into y squared times the cubed root of y. So when we put these things together, we have 2 y squared is what's outside the radical, because the 2 and the y squared. And then what was left, oops, that's too close. Still too close. What was left inside the radical was a 2 and a y. So when we simplified the cubed root of 16y to the 7th, we had to take the cubed root of 16, which we said was 2 cubed root 2, and we had to take the cubed root of y to the 7th, which was y squared, times the cubed root of y. And then to find our simplified answer, we just throw all the information back together. So what was left underneath the radical goes underneath the radical together. What was left outside the radical goes outside the radical together in its multiplication. We'll get a lot more practice simplifying here, and a lot of them will be prettier than this and not this difficult, but I figured I'd show you a kind of hard one on the video. Okay. Last example, one more. So here, these aren't really radicals. It's just a complicated simplifying of exponents that we really didn't get into yesterday. We didn't have anything this difficult, so I threw it on the video because we will see something like this in our textbook problems tomorrow. So 4xy, we can't simplify that, so that's going to stay. So we have 4xy. And if we remember from our exponent properties that we learned in class today, when we have a variable or a number raised to an exponent, and that exponent is being raised to another exponent, we multiply our exponents together. And that was called the power of power property, for those keeping score at home. So we have x to the 1/5. So we have x to the 1/5 times 5/2. We need to distribute that 5/2. And then we have y to the 2/5 times 5/2. So I distributed that 5/2 to the x and the y. Well, my 5's cancel. My 5's cancel. So I still haven't done anything with 4xy in the numerator. X, my 5's canceled, so I'm just left with x to the 1/2 in the denominator. My 5's canceled, so I'm left with y to the 2/2, which is just y. And now we need to remember, well, how do I combine exponents when I'm dividing? Well, we subtract. So my y's cancel. X to the 1st divided by x to the 1/2 is x to the 1 minus 1/2, right? Here, let's write that neater. X to the 1 minus 1/2. Well, 1 minus 1/2 is 1/2. So this would simplify. So 4xy, all the complicated stuff in white in the original problem, simplifies and is actually equivalent to just 4x to the 1/2. And this is an unnecessary step, but since we talked about converting from exponential to radical form, let's just go ahead and do that just for extra practice. So x to the 1/2, the 4 stays. X to the 1/2 means that the outside of my radical is 2 and just x. So x to the 1/2 is the same thing as the square root of x. All right, I know we covered a lot in this video, and it was really, really long, but it was our introduction to radicals. So simplifying exponents here, the denominator of the exponent goes outside the radical. The numerator of the exponent is what we are raising our radical to. That's the radical property right there. And then when we're simplifying, we have more properties to go over. So hopefully we took notes over this and it made some sense. Be ready to work on this in class tomorrow, and then ask me any questions that you had over the video. You can ask me at the start of class when we're working an example problem. Hope you all have a good night, and I'll see you on class tomorrow.